let's look at this example. So I have a statement 1 while some condition, let's say R1 is greater than R2, then do statement 2, then another while loop, and this is R3 is less than or equal R4. And inside of this, I have statement number 3. And then I have statement 4. And then I have statement 5. Now, how can we generate code for this? Remember those instructions, the compare. So we need to use compare. Here, it's going to be compare greater than for the first loop. And for the other loop, we're going to use compare less than or equal. And this compare is going to compare R1 and R2. And it's going to put the result into some register. Let's call it Rx. And then we're going to generate code. We're going to conditional branch based on Rx to L1 or L2. Okay, so now let's see. Okay, so let's now, so we'll generate code for statement 1, whatever that statement is. Then we have this while loop. So we will need to generate a conditional compare R1 and R2 and put the result. And now suppose that we have these registers allocated already, R1, R2, R3, R4, and you have that get next register function, so it's going to give you R5. Okay, so it's going to give you register R5 for this. And R5 is going to have the results. So we are going to do conditional branch on R5 to conditional branching to, if it's correct, then we will go to the, let's call it L1 underscore B. So B stands for the body of the loop. By the way, this is the format that I want you to use. So if it's correct, we'll go to L1, or let's do it L1B. Otherwise, we go to L1 out. So L1B loop body, L1O is out of the loop out, and L1C the checking or loop condition. So in fact, we need to introduce a label for the compare because inside the loop we want to jump to this. So we're going to jump to L1C for compare. So this is the label. And this is the loop body. The loop body is going to have in it what? Statement 2. And this is the loop 1 out. So what should we put here?
For statement 5.
Statement 5.
Yeah.
Statement 5 is what's the first instruction after the loop. So loop out is the first instruction after the loop. Okay, so this is statement 2. Then what should we do? generate code for this. So you will call that same function, recursively call that function that generates code for a while. And the code for the while is going to be conditional branch, compare R3 and R4, put the result in the next register, which is R6, and conditional branch based on R6 to L1B or L1O. So B for body, O for out. Same thing. I will have.
Isn't it supposed to be L2?
Yes, sorry. Thank you. Yes, L2. Because this is a different loop. Thank you very much. Yes. Now, we will have to do the same thing, right? Well, maybe we should have completed the generation for the outer loop. So what remains in the generation of the outer loop? In the code generation for the outer loop? What are we missing in the code generation? Forget about the loop body. So this is the body of the outer loop. What are we missing in the code generation for the outer loop?
Right before L1 out, we have to have a jump to go back to L1C.
Yeah, exactly. So we need this jump immediate to L1C. Because this is the end of the outer loop. 1 is the outer loop and 2 is the inner loop. So we'll do the same thing for the inner loop. Now, the out for this loop is going to be, what will be the out for this loop? Which statement will be the out for the inner loop?
Statement 4.
Yeah, exactly. So it's going to be
Statement 4 right before the jump.
Okay. So I now I discover something else that I missed. Yeah, it's statement 4. That's true. So it's statement 4 is going to be L2 out. This is statement 4. I just missed what kind of compare this is. So this is compare
Greater than.
This is compare greater than, and this is compare less than or equal. I missed this. Okay. So now this is, and similarly we need a jump immediate. Jump immediate L2C. Okay, so this is basically the body of the inner loop. Now the body of the inner loop starts with, in fact, it has only one statement in it. So it's going to be L2 body. L2 body will have statement 3. And then jump immediate to the condition. Okay. What are we missing? There is something missing. I can see at least one thing missing.
Well, we do need the label for the inner loop compare.
Okay. Yes.
It should be right there at the compare.
Yeah. So here we have L2 condition. Okay. So each loop will have 3 labels: one label for the condition, one label for the body, and one label for the out. The first instruction after the loop. Okay. So are we missing anything here? Okay, so let's make sure that we are not missing anything. So statement 1 is there outside all loops. Inside the loop we have statement 2, and then the while loop, and inside the inner while loop we have the body of the loop consists of this, and then a jump immediate. Let me put the jump immediate here. And then statement 4 is the output or the out of the inner loop. Then I need a jump immediate for the outer loop. And And then I will need the out statement for the outer. Okay. So how many people have already written this? How many people have already implemented this? Implemented the code that generates this?
Not yet.
Okay, so this is an important part of the assignment. And remember that this is recursive. So you have to have this function for generating, systematically for each loop, generating these 3 labels. And remember, this is based on the abstract syntax tree. So you have a while. And the while will be in a statement list. So this while will be in a statement list. So in this case, in fact, you'll have this. Let's put it this way. Statement 1, while, and then what comes after the while in the statement list?
Statement 5.
Statement 5, exactly. So in the statement list, if you have a next pointer for every node, okay, the next of the while is going to be statement 5. But where are you going to have this? So where will you have the inner loop?
It'll be hanging off that while there. It'll be
Exactly. So the while will have, it will have a next. So let's make it a funny note. Okay. Okay. So there is a next. The next points to ST5, and then there is the. It will have that condition, and it will have the body. So each while loop. So this is the abstract syntax tree. There is a condition and there is a body of the loop. And the condition may have a whole, in the assignment, it's not going to be as simple as this. In the assignment, it can be an arbitrarily long and complex logical expression. So again, this can have a whole tree below it, because this can be an arbitrarily long and complex logical expression. And this body is what?
another statement list.
A list of statements. So this is going to be another statement list. And this statement list is going to have statement 2. And in the list after statement 2, you will have another while. And after the while, you have statement 4. So this is the other list. And this while will have a next, and it will have a condition. And it will have a body. And the body of this inner while will have only one statement in it, which is statement 3. Okay, so basically, these are two conceptually. The next pointer is a conceptually different pointer than these pointers to what constitutes the while loop. So these two pointers are the pointers to the two components that constitute the while loop. A while loop consists of a condition and a body. This is a different concept. This is a pointer to what comes after it in the list of statements that it belongs to. And it depends on how you program it. But if you are programming this in an object-oriented language, for example in C++, then this next pointer, well, logically, in fact, conceptually, this next pointer should not belong to the while node. It should belong to the while node in particular. It should belong to any node, any list element. So for every list element, so while as a list element, it will have to have a next as a list element. But while as a while, it has a condition and a body. How you implement this? The easiest way is to put all of these possible pointers inside of the AST node. So you can make this AST node class or structure, and you can put everything in it. This would be the easiest but it will not be the most elegant way of structuring this. So the AST node, you just put into it a condition, a body, a then for the if statement, and else if this node is and a next. And you don't have to do an elegant object-oriented design in this assignment, but ideally you would like to. An AST node should have only the elements that belong to all nodes, and you derive from the AST node. You derive a while node. So you derive a derived class for a while node, and the while node will have in it, body and condition. And an if node will have whatever is specific to the if node, which is a condition and a list of statements for the then part, and a list of statements for the else part. And an add node will have its different structure, the different fields. So for the add, you will have to have the left hand side expression, or expression 1 and expression 2, whatever. So ideally you would like to have a derived class for each node type that has the fields that are specific to this type. But if you put everything in one generic node, that will work. It's fine. It will work fine. Even though I want you to understand that this is not the best way of designing this. This won't be elegant design, but it will still work and may simplify things. And we are writing this in C anyway.